So, guys, so this problem is related to the magnetic disk, right? So, in the last class, we have seen few problems regarding this magnetic disk, right? So, basically, if you take any kind of a disk, that disk contains a collection of platters, right? This platter will internally contains a set of tracks where each set of tracks are again divided in the form of sectors, right? And each sector contains a data, right? We can define this data in terms of density, meaning that density means what? Number of bits we are going to store per centimeter, right? So this is a problem which is related to the magnetic disk, right? Here they have given number of read-write heads are 160, meaning that per platter you are going to have read-write heads. So as you are going to have number of read heads are 160, we can say that number of surfaces are 160, and outer diameter they have given inner diameter, inner track space, maximum density 2048 bits per centimeter, number of sectors per track is 128, compute the capacity of the disk, right? So we can do it in many ways, right? So I will try to do it from the reverse order, right? So first I will try to find out capacity of the disk, right? How can we calculate the capacity of the disk? Total number of surfaces, right, into each surface contains number of tracks, each track contains number of sectors, and each sector contains data, sectors and data, right? Now, is it possible to solve this particular problem with respect to these parameters, with respect to these given parameters? See, we know number of surfaces, that is 160, and do we know the number of tracks? Is they have given anywhere? No, they haven't given. But can we able to calculate the number of tracks? Can we able to calculate the number of tracks? Try to observe. If you take the shuffle, so in the middle it is a shuffle, right? Middle it is shuffle, right? Meaning that at this portion there is no data. This is a cylinder. You don't have any data. I hope you understood, right? Yes. Now they have given clearly. They have given clearly inner diameter. They have given clearly inner diameter, meaning that the innermost circle diameter they have given. Meaning that if you are able to observe this to this, right, this is what inner diameter. And what about the outer diameter? Outer diameter they have given. So meaning that the outer circle diameter also given. So from other side corner to this side corner, right? So this blue line defines outer diameter, and this green color defines inner diameter. Inner diameter, right? So guys, tracks are available in which location? Tracks are available between the available space between the inner radius and outer radius. Inner radius and outer radius, right? So if you are able to calculate the distance between the inner radius and outer radius, can I say that my tracks are available in this location or not? Yes. And also they have given the inner track space clearly. What is inner track space? Width of the inner track space is 0.1 mm. If you are able to calculate the distance between the inner radius and outer radius, definitely I can say that my tracks are all available here, right? So can you able to calculate the distance between the inner track and outer track? Yes or no? They have given here diameter. Do we need to calculate from on the diameter or the radius? Radius, right? So what is the radius of outer diameter, outer circle? 8. What is the radius of inner circle? 2, right? So which is 6 centimeters. So the actual tracks are available in 6 centimeters radius, right? On the 6 centimeters radius, each inner track capacity is what? 0.1 mm. 0.1 mm, which I can calculate as 600 tracks, right? So the number of tracks you got as 600. I hope you understood, right? Meters are converted into millimeters, are converted into centimeters, or centimeters converted into millimeters, any order, right? So if you are able to observe, so the total number of tracks are here 600. What about the number of sectors? 128. What about the data size? So data is what here? Data of each sector. Data size of each sector, right? Is there any given this parameter? Is they have given this parameter data of each sector? No, they haven't given. They have given only density. They haven't given the data of each sector, data size of each sector, right? Then this particular procedure is not possible for us. Am I right? Because this particular parameter is unknown, I cannot able to solve it. What is another solution? Can I go with another way? If I try to write the formula in such a way that number of surfaces into, you know the number of tracks easily, and can you able to find each track capacity? Can we find each track capacity? Each track capacity is equal to the number of sectors into data of each sector, right? So now can we able to find out each track capacity? You know, number of surfaces are 160, number of tracks are 600, and each track capacity is what? Each track capacity is how much amount of data that I am going to store it one track, right? Can you able to calculate the size of one track? Size of one track, I can say it as simply circumference of one circle. Am I right or not? Circumference of one inner circle. What is circumference of inner circle? 2 pi r, right? So 3.14 into, what is the value of 2r? Which is 4 centimeters. So I can say that this will be 12.56 centimeters. So one inner track capacity is 12.56 centimeters. 12.56 centimeters, right? Now, in 12.56 centimeters, how much data I can able to save? How much size of data I can able to save? They have clearly mentioned 1 centimeter we can able to save 2048 bits. 2048 bits. For 12.56 centimeters, how many bits I can able to save? Right, you know, right? 2048 into 12.56. 2048 into 12.56. That you can able to calculate. What's the value you are going to get? Tell me. 2048 into around you are going to get 25,722.88 bits, right? So which you can do 25,722.88 bits. This is the total capacity of the disk, right? So based on this one, according to the question, you can able to convert. If you want, you can able to convert into bytes or megabytes or gigabytes, whatever it may be. If they are specifically asking for in terms of bytes, what you can do most simply, you can divide with 8 so that you can get the answer in the form of bytes. I think your answer will be around 1929216 bytes, which will be around one, not exactly. Exactly, you can able to calculate this one. Is it okay for everyone? Right? If they haven't given, so based on the given parameters, you have to calculate it. Right? So the reason why I have moved for another formula is you don't know the sector size actually. If you know the sector size, definitely you can go for this particular, the earlier one. As you don't know the sector size, I tried to move for each track capacity. Each track capacity you can directly get it with help of how much area it is occupying, the one of the track. Right? And you know, in the previous class I have given one assumption. The outer circle track size is equivalent to inner circle track. Based on that assumption, this particular problem is true, right? But there are certain kind of questions, they will specifically mention outer circle is not equivalent to inner circle again. Right? Based on that you have to. Here the assumption is outer circle track size is equivalent to inner circle track size. That's why I have gone for this one. So that's the reason only I have taken only circumference of inner circle. If you take the circumference of outer circle, again your answer will change, right? So you have to make sure according to the question. Next one, try to solve this one. So they have given clearly disc pack has 19 surfaces, outer diameter is 33 centimeters, inner diameter is 22 centimeters, maximum recording storage density on any track, see, observe, on any track 200 bits per centimeter, minimum spacing between the track is 0.25 mm, calculate the capacity of the disc. Again, which look like the same earlier problem, right? But here there is slight difference in terms of this particular point. What is the meaning of this one is, minimum spacing between the track is 0.25 mm, meaning that if you are going to think that this is a kind of a plotter, this is a kind of a plotter, on every track, see, if you are able to observe, this is a kind of a track, on every track there is a gap of 0.25 mm, meaning that this particular highlighted track, highlighted path cannot be used. This 0.25 mm cannot be used for anything. It's a kind of just simply a gap, right? Based on that, you can able to calculate the number of tracks, right? Now, if you would like to find out the capacity of that disc, what you required? You required to find out number of surfaces and number of tracks, and can I write directly size of the track? Am I right or not? I can directly write the size of the track, right? Now you know number of surfaces are 19. How many tracks are here? Can I say? So I need to find out the difference between the inner track radius minus outer track radius modulus, right? Meaning that 16.5 minus, is it correct? 33 by 2, 16.5 and 22 by 2, 11, right? 16.5 minus 11, which is the space, right? So which is equivalent to 5.5, it's equivalent to 5.5 centimeters, right? So meaning that you have find the radius of inner track, I mean space occupied for the inner circle radius minus outer circle radius, But here they have added one extra point. The minimum spacing between the track is 0.25 mm. 0.25 mm, meaning that this is actual space. On this space, how much amount of memory space they are wasting? Again 0.25 mm is wasting, right? You can able to calculate. What is the value you are going to get? You are going to get 220 tracks. Hope you understood, right? You are going to get 220 tracks, right? Now once you know the tracks, can you able to find out the size of the track? Again, right? You know the inner track capacity is 2 pi r, circumference is 2 pi r. So 3.14 into, I can directly take as 22 centimeters. So 3.14 into 22, which is equivalent to 69.08 centimeters. 69.08 centimeters, right? So this is the area covered by one track, right? So now for this you are going to save 200 bits per centimeter. 200 bits per centimeter, right? This centimeter is going to be cancelled. So 69.08 into 200 bits. So total how much capacity it is going to save means 13,816 bits are going to be saved, which is equivalent to 1727 bytes. 1727 bytes, right? Now we can able to substitute here 1727 bytes. So your total result will be approximately equal to 72,000. So it's not 72,000. It will be this many number of bytes. If I am going to convert into MB, which is equivalent to 6.88 MB, right? So I have moved very fast because which is same as the earlier question. The difference is you need to remove this space. This space is not at all useful for us, right? That's why I have divided with 0.25 mm. Any doubt? 2 pi r? Pi is 3.14. 2 into r is diameter, right? 2 into r is diameter, that is 22 centimeters. I have mentioned directly. Okay. Na? Try to solve the next one. I think this question I have given in the last class. Are you right? CRs have shared it. You can check with the question. So here you can able to easily calculate the capacity of the disk, right? So they have given 32 surfaces, 256 tracks per surface, 512 sectors per track, and 1024 bytes per sector, right? What is the capacity of the disk? So you know total number of surfaces and total number of tracks per surface, and each surface contains 512. Sorry, each track contains 512 sectors, and each track capacity is, each sector capacity is 1024 bytes. Right? You can able to solve it. You can get the answer. Right? I think you have solved it already. Right? Good. What is the value you got in terms of MB? You can say, or whatever the value you have calculated, you can just tell me. 4 GB. 4 GB or 4 TB? 2 power 30 na? 2 power 30. 2 power 32, which is 4 GB. Right? So, which is I think 2 power 5, 2 power 8, 2 power 9, 2 power 10. Right? 5 plus 8, 13, 13 plus 9, 22, 22 plus 10 is 32. 2 power 30 is GB, and 2 square is 4. So, total answer is 4 GB. Right? Yes. So, here the second one is somewhat different, that's why I have taken this one. Number of bits required to address the sector. Right? What is the meaning of this one? If I am going to have n sectors, how we will give the naming for each and every sector? That's what, right? So guys, if you are going to have 8 bits, if you are going to have 0 to 7 numbers, 0 to 7 numbers, how we are going to address these 0 to 7 numbers? You address in the DLD. How we are going to identify the address for these 0 to 7 bits? You require only 3 bits. You require 3 bits, right? Similarly, if you are going to have the values from 0 to 15, how many bits are required? 4 bits. That is what they are asking simply. Number of bits are required to address. Address means what? 3 by something like, if I give some address 3 bar 54, it's a kind of address like home address, right? So if it is unique, then I will go to that house, right? Similarly, if I want to have the numbers from 0 to 7, if I would like to give the unique values to that, how many bits are required, right? So if I am going to have 3 bits, definitely I can give the values from 000, 001, 010, 011, 100, 101, 110, 111, right? Try to observe. For 8 values, I have given the names uniquely. Each one I can represent as one address, one unique address. That is the meaning of this one. So now, here, in order to identify the sectors uniquely, meaning that in order to provide the addresses to every sector, number of bits are required. That is what they are asking, right? So for that, can you able to find out the first number of sectors? Number of sectors are how many? 32 surfaces, 256 tracks, 512 sectors. That's it, right? So you can able to get total number of sectors. So total number of sectors are 2 power 5 into 2 power 8 into 2 power 9, which is equal to 2 power 22 sectors. 2 power 22 sectors, right? So how many bits are required? 22 bits are required in order to find the address of every sector. In order to identify every sector uniquely. I mean, see, basically you are going to have many sectors. Many sectors. For every sector, it is going to give the unique value. If you want to give the unique value, you can just simply take 21 zeros. Fine. First is 22 zeros. Next one is 21 zeros followed by 1. Next is 20 zeros followed by 1 0. Next is 20 zeros followed by 0 1. Next is like that. Like this, it is going to allocate for everything. It is going to allocate one unique unit. That's the meaning of this one. So every sector, it is going to provide one unique unit. That is what the meaning of this one. Okay, now I think the remaining two questions you can solve it, right? Question number C and question number T, which we discussed earlier one. Right, I think they have mentioned something like 3600 and RPM. You need to find out the disk transfer rate. That is the C question. And D question is they are asking for average access time, right? So these two we discussed earlier already. This kind of models you can able to solve it. Okay. Next one. So try to solve this one. So today morning group in Get group this question was posted already, right? Any other answers? Net lo chudadanu. 14.02 seconds. Okay, good. I think they have asked here in milliseconds. 14,020. Good. And again, the question you had. This is again a numerical question actually in GATE. I mean, we need to fill the blank. Right? So let me read the question. Consider a disk pack with seek time of 4 milliseconds and rotational speed of 10,000 rotations per minute. Right? So when you got any kind of question, any kind of question, so you need to write those parameters. Right? Better. Right? Seek time is 4 milliseconds. Okay. And rotational speed is 10,000 rotations per minute, meaning that they have given RPM value as 10,000 rotations, meaning that for 60 seconds they are going to rotate around 20,000 rotations. It has 600 sectors per track. So one track contains 600 sectors and each sector can store 512 bytes of data. 512 bytes of data. Consider a file stored in the disk. The file contains 2000 sectors. The file contains 2000 sectors. Assume that every sector access necessitates a seek and average ring latency. What are the meaning of this one? Whenever they are going to access every sector, they need to perform a seek operation as well as average ring latency time. Average rotational latency time for accessing each sector. So average rotational latency for accessing each sector is half of the time for one complete rotation. Meaning that what I have mentioned clearly, if they haven't mentioned any kind of rotational latency, what you have to do? 1 RTT by 2 is the ring rotational latency. Rotational latency is 1 RTT by 2 and the total time needed to read the entire file is. So finally what they are trying to ask? They are asking for what is the access time, right? So access time means, what is the formula for it? You know, seek time plus rotational latency plus data transfer rate or data transfer time. Right? So they have clearly mentioned seek time is 4 milliseconds and ring latency is 1 RTT by 2. 1 RTT by 2. I mean, you need to calculate 1 RTT. What is 1 RTT value? So you can able to calculate what are the meaning of one rotation. One RTT means one rotation, right? So from this one, can you able to get one for 60 seconds? It is going to rotate for 10,000 rotations. For one rotation, it is going to perform 60 by 10,000. 60 by 10,000, right? So which is again in terms of seconds, right? So can you able to do it in terms of milliseconds? This 0 cancel. Then can I write this 1 by 1000 as millisecond, right? So for one RTT it is going to take 6 milliseconds. So it will be 6 milliseconds, right? 4 milliseconds plus 6 milliseconds by 2 milliseconds by 2 plus what is the data transfer time? Data transfer time 0. Okay, 0.01 milliseconds. Very good. So any other answer? How you got 0.01 milliseconds? See, you can able to equate, right? In the last class itself I have mentioned. For one rotation, it is taking 6 milliseconds. It is taking millisecond, right? For 6 milliseconds, how much data it is transferring? How much data it is transferring? 600 into each sector is going to take 512 bytes of data, right? So I can say that 600 into 512 bytes of data. What does the meaning of this one? For 6 milliseconds, it is transferring 600 into 512 bytes of data. What is our requirement here? For transferring 512 bytes of data, for transferring one sector, right? So if you are able to calculate for 512 bytes of data, what you are going to do, right? So if I calculate it, 512 is going to be cancelled. This I think it is going to be cancelled as hundreds. So which will be 1 by 100, right? So data transfer time is 1 by 100. So which is equivalent to 0.01 milliseconds. 0.01 milliseconds, right? So I can say that this will be 0.01 milliseconds. Okay now. So this is the answer? No, this is not the answer, right? Why it is not the answer? So we transferred here what data? We transferred for only one sector, but our file is available at how many locations? 2000 sectors. So each sector requires one seek time along with rotational latency. So I can say that I can simply multiply with 2000. Can we able to add it for data transfer time? Do we need to add it for data transfer time? Or only this particular equation is correct? We need to add it for all the things. So this is all meant for to transfer one sector, but they are asking for to transfer 2000 sectors of data, meaning that our file is distributed over 2000 sectors. So finally we need to multiply with 2000, right? So this will be 2000 into what is the value? 7.01. So which is equivalent to 14.020 milliseconds or seconds. This will be seconds, right? If you are able to convert into milliseconds, 14.020 milliseconds, right? These parameters are very important. Milliseconds and seconds, nanoseconds, all those things, right? 1 nanosecond is equal to 10 power minus 6 or 10 power plus 6? 9 micro 6, right? Okay, fine. So is it okay for everyone, this particular question, right? Here finally, so everything is correct perfectly. Here finally I multiplied with 2000 is because of our file, the file contains 2000 sectors, means this file is distributed over 2000 sectors. I need to transfer the entire file. That's why finally I multiplied with 2000. Right? Okay. We can stop here.